All right, so I promised you last week that we are going to be able to answer just about anything in organic chemistry if you know what the electrons are going to do. That's the overarching question. What are the electrons going to do? In order to answer that, we're going to consider two things: shape and electron density. Right. So virtually everything we do is targeted toward understanding electron densities and shapes. Electron densities come from stabilities and electronegativities, pKa's, and shapes come from shapes, right? So if you somehow have some facility with three-dimensionality, you're really golden. But those of us who don't have to work at it. So what we've got is some very convenient notation in organic chemistry that was I'm going to claim is going to sit nicely in your eyes once you get it, but it's going to take some work. You have to understand it. So let's look at the first set of notation. Well, actually, we looked at hashes and wedges last week, didn't we? So we got hashes and wedges last week. This week, we're going to do Newman projections, okay? So here's how a Newman projection works. A Newman projection takes into consideration that single bonds rotate, right? Single bonds rotate, and they rotate constantly. So at any temperature above absolute zero, these single bonds are constantly rotating. All right, so we looked at wedges and dashes last week. Does this look familiar? Where this hydrogen, where's my red here? This hydrogen right here is coming out toward us because it's wedged. That hydrogen's coming out toward us because it's wedged, right? That one's going back behind the plane of the paper or the screen. That one's going back behind, and this is in the plane of the paper or the screen, okay? Those ones are all flat, all right? So we can look at the same thing if we turn it a little bit. That's what this little arrow here is. If we turn it a little bit, we have another representation called sawhorse. And sawhorse is fine. It's not as descriptive as wedges and dashes, and doesn't sit in your eyes as nicely, but perhaps you can see it just fine. Now we're going to introduce two Newman projections. And this is a little bit counterintuitive, or I should say almost, unartistic, but it's going to work nicely, okay? So Newman projections are ideal for comparing the relative stability of possible conformations around that single bond. So can you see, here's these three hydrogens, right? And they're attached to that carbon right there, right? And can you see that they're offset, right? We're going to do a lot this chapter with what that offset means, okay? But they're offset, right? So, and if you can see that, you're good. Now let's see how we build a Newman projection. Let's see. All right, so here's how we do it. Well, a Newman projection is as if you're taking your eyeball and you're looking straight down that line, okay? If you're looking down that line, can you see how this person who's looking, they've got a hydrogen going up and another hydrogen in there, right? Those are the three reds that are closer to this person's nose. Okay? Yeah, this person loves what's going on here. Teeth. No, that's ugly, isn't it? Okay, we'll just keep it like we got it. Teeth. How about a little bit of teeth? Still a little creepy, but anyway. All right. So here's this guy. He needs eyebrows, doesn't he? All right. So here's this guy. He's looking down the axis of this ethane, okay? And he's got the three red hydrogens, which are closer to him, all right? So here's the part that's unartistic. You can imagine that if we were drawing this by perspective, the carbon that was further away would actually be smaller. But with Newman projections, we can't see it if we do that. So we draw the behind carbon up really big like that. So this is that carbon right there is actually, it's exaggerated. It's a big ball, right? And we make a vanishingly small ball for the front one, all right? It's just a notation. It's artistically, I think, a little bit backwards, but it works very nicely. And once you get used to it, you're going to be good. So let me show you an example of that. So I pulled up a software. By the way, this is a free software. It's called Avogadro. It's free and it's platform independent because it's Java, and so I think it's Java. So you can download this on your computer and make stuff up and you have like a virtual model set. So. All right, so what I've got here is I made one of these atoms yellow just because I felt like it. It's still a hydrogen, but I just colored it yellow so we could see it. Can you see that here's an ethane molecule, hydrogen, hydrogen, hydrogen. Actually, what I can do, I bet you I can make these three guys red, like the three hydrogens that were there. Let's make those three red, right click, change color, boom, okay, oops, change color, red, okay. Not sure why this is doing this, but let's do all three of them. Change color, okay. Now let's take this guy, let's turn this around, and make these three blue, right? You see what we're doing? We're going to build that molecule like we had in the previous one. I don't think I can do all three at once. It doesn't make sense, but. All right, reset color, change color, blue, okay. Change color, blue, okay. Change color, blue, okay. All right, so now we actually have the molecule that we have. I'm going to reset this. Select view. Let's reset the view. It's getting too big. Center. Okay, so there it is, right? Okay, so let's take this and let's go back over here and say we had three hydrogens, right, that are red and three that are blue, and that's what this is. So you can see now what I want to do is I want to turn this around. That's what I'm doing with this, what that guy is doing with the scary face. He's turning around, he's looking at it like that, okay? Now you can see this is artistically, the model I have in front of you is artistically set. So the big circle is actually the carbon in the front. But the convention for Newman projections, so that you can see it, is to make the big one the one in the back, okay? All right, so anyways, you can see that the reds and the blue are offset, right? So no matter what I do, they're going to be offset. I can't line those guys up. So I just turned it around and put the blues in front. You see that? Okay. So I'm going to take that, and I'm just going to leave it there, I guess. So let's come back over here and say that's what this guy's looking at, all right? And Newman projection is very, very useful to evaluate the offset of the atoms that are bonded to two particular carbons that are touching each other, okay? The front carbon and the back carbon. All right, another example would be if we have, can you see that we've got a chlorine and a chlorine over here, where's my marker here? A chlorine and a methyl group. And can you see that they're in the same plane, right? Here's carbon 1, here's carbon 2. So here's what I'm going to do. Every time I do this, I'm going to draw it like that, then I'm going to draw it like that. Carbon 1 is up front, and carbon 2 is behind, okay? And can you see that one, let's see, this methyl group here and this chlorine, since they're flat lines, they're both in the plane of the screen. So if they're both in the plane of the screen, that means that they're with each other. And oops, I drew this upside down because if this is me looking, okay, if this is me looking down that, do you see that the carbon is actually going down toward my chin, right? So I drew this wrong. Let me erase this. Erase that. I'm going to redraw it. The one in the front is going down. There's my carbon going down, right? So this carbon in the front is carbon 1. That's carbon 2. Ooh, numbering saves me again and again and again. So on carbon 2, I've got a chlorine atom. Can you see I've got a chlorine and a methyl group? This is a CH3. Okay. So if I got my chlorine, it's right there. And can you see this is my right ear, okay? And on my right ear, this, oh, that's going, that methyl group's actually going toward my left, right? It's going behind the screen. So that's going over toward my, see, I got my left hand over here. Okay, that's my left hand. There's my palm, dirty fingers, thumbnail, okay? And my right hand is over here, okay? Okay, I don't have much of a shoulder there, do I? But there we go. There's my left hand, right hand. Can you see that this methyl group is going back more toward my left hand because it's a hash, right? So this is now, I'm turning it toward me. The methyl group must be over here, CH3. Okay, and this methyl group's going down, so that's CH3. And everything else is implicit, right? So those must be hydrogens. All right. And that's how we do Newman projection formulas. We're going to be doing them over and over again. And I encourage you, as always, I encourage you to practice and practice and practice, and you'll get it. It also helps to use model sets. I don't have my model set here with me, so I pulled my electronic model set out here, and there you go. All right, hope that's helpful.